So yesterday class we will start with that basic structures of the basic structure of our traction system. So now we are discussing about the power supply of the traction. Am I audible properly?
Yes, sir.
Hello.
Yes, sir.
I think my slide also visible from your end. Is it changing?
Yes, sir.
लेमिनार फ्लो है.
So we are discussing with that power supply of our tractions, means conventional traction system, means EMU system for Indian Railways. Okay, so we are discussing about the pantograph. Okay, so pantograph, the main thing is that there are some constant. You can see different parts are there, like that. That is contact strips are there. Okay, so what is that contact strip? So here your contact wires are there. Okay, from the picture you can see the contacts wire. Okay, so these are your contacts. This is your contacts wire. It is connected over there, and it touching with your pantograph strip, and pantograph can collect the current from there. Okay, you see the some horns are there and pantograph arms. Okay, so you can move that pantograph arms are movable in nature. Okay, so why they are in movable in nature? So based on your there is some compressor that is called baby compressor. Okay, inside of your EMU machine coach. Okay, so the purpose of that baby compressor that can uplift. Okay, that can move, that can responsible for movement. Okay, that movement of the pantograph. Okay, so here you can see some conductor rail system. Okay, so it is called conductor rail system or overhead system. Okay, so we are discussing about the overhead system. Okay, and here you can see different parts of the pantograph. Okay, so from the structure you can easily understand how it will be look like that. So here you can see that it's your railway track. Okay, railway tracks are there, and beside of your track, so some regular interval, there are some regular interval. Okay, so after some interval, some post. Okay, so here you can see some poster connected. Okay, so for poster connected to holding your overhead lines. Okay, so overhead lines, then you can see some arms are there. Okay, so arms are there that can connect. Okay, that can carry the overhead lines. So overhead lines having two wires. Okay, one is called catenary wire, another one is called contact wire. Okay, so first one is your catenary wire, this is your catenary wire, and second one is your contact wire. Okay, and now what is the purpose of that catenary wire? The purpose of the catenary wire to provide the electricity. Okay, to provide the electricity or the proper current symbol, current continuation of the current flow in the contact wires. Okay, second line is the contact wire. So catenary wire and contact wire both are connected through the dropper. Okay, so here you can see that arm will connect the contact wire. Okay, the shape of the contact wire is look like a 8. Okay, so if you see the cross-sectional area of the contact wire, it's look like 8. Okay, and that especially designed with that solid metals. Okay,
Sir, the
it is
slide has
normal.
not changed.
Hello,
Slide has not changed.
which slide you are you can see right now?
Power supply and electric traction.
Okay, next slide it didn't come. Now overhead line catenary is not coming.
No, sir, it is not there.
Yes.
Maybe some delay is there, some network issues is there. I'm telling you, na, very laning is there. So sometimes some delay is there. So I'm not changing the slide. Okay, you just listen carefully, whatever I am telling. Okay, so based on that, so I'm not changing the slides. Okay, you just listen carefully, whatever I am sending you. telling you. So I think the slide maybe change after some time. You can see like that. Okay, so but again I am reshare it. Okay, I'm reshare it. So let's see. Actually, my MS Team also not working. Means what software I have installed that is not working. I am opening that MS Team from browser. Okay. Is my slide is visible from your end?
Yes, sir.
Yes, sir.
Is it full screen now? Okay, so here you can see that two wires are there. So upper one is called the catenary wire. Okay, so it is an ACSR conductor. Okay, aluminum conductor, steel reinforced. Okay, so ACSR conductor, and you can see that contact wire. Okay, second wire is called the contact wire. Okay, so contact wire are in solid wire. It is not a ACSR wire. Okay, it's the cross section area of that wire is like a 8. Okay, and it's the compositions, that metal compositions of your cadmium and copper. Okay, both are connected. You are making some amalgam. Okay, so and you are getting that compositions. Okay, the solid bar compositions of this contact, these two elements. Okay, and you are preparing that contact wire. Okay, pantograph is touching your contact wire. Okay, and you can see some contact wires are connected to the catenary wire through the dropper. Okay, so with some regular interval, you can see some dropper wire are there. So these all are the droppers. With regular interval, it is connected. Okay, and make connections in between contact wire and the catenary wire. Okay, and here you can see some insulators. Okay, so as you know that lines are holding. Okay, that you can see that arms are holding your quaternary as well as contact wire, so that there is a high chances, still the insulation is there is a high chances to coming electricity to the arms of that to the arms of that angle. Okay, metal angle. So that's why you can see some insulators are connected with your RCC pole. Okay, so no current should come to your RCC pole. Okay, and here you can another wire is there. You can see that parallel return wire. Okay, so another wire is there. If any returning path is required, sometimes what happen for protection purpose. Suppose there is a, if you see your street electricity. Okay, I hope that in your city or where you are staying, so you can see that there is some RCC pole just in front of your home. Okay, so where the wires are connected, so you can see there are 6 wires in your pole mounted. In your that 6 wires are there. Okay, upper wire is your for the protection purpose, that is called galvanized iron wire, GI conductor. GI wire. What is the purpose of this GI wire? So any kinds of any times that is there, so lightning is there. Okay, so directly that GI wire is your body ground, connected with your body ground, and it can pass the additional charge from your due to lighting to your pole to ground. Okay, that is for protection purpose. So same thing also here connected in this circuit, not circuit directly that pole. So one GI wire is there, that is for the protection purpose. This is also called the parallel return wire. Okay, so in your street lighting, you can see not lighting in your street. Okay, the poles are there, RCC poles are there. I told you that there is a 6 wires. So first one is your GI wire. So after that, next 3 wires are your 3 phase lines. Okay, RYB phase wires are there. After that, you can see your another line that the that wire conductors. These all are the ACSR conductor. Okay, then so first one is GI conductor. Then 3 lines are there, that is phase line. So out of 6, 4 lines are completed. Then fifth line. Okay, fifth wire is there. If you see the cross sectional area of that fifth wire is quite less. Okay, so quite less compared to the other phase wire. Okay, what is the purpose of this fifth line? That fifth line is here for street electricity. Okay, so street lighting. So in your street, you can see that in the pole that different maybe you can say like that RCC posts are there. Okay, so you can see different street illuminations, different lamps are connected, maybe halogen, sometimes fluorescent lamp, sometimes now most of the cases you can see LED lamps are there. Okay, with most of the cases. So that street lighting is connected that fifth wire, and sixth wire is your neutral wire. Okay, so and that neutral wire is grounded in your pole mounted substations. Okay, what is your pole mounted substation? In your locality, you can see that there is some transformer. Okay, there is some transformer that is directly connected or installed nearer to your domestic, nearer to your locality. Okay, suppose in your area, okay, there are maybe that transformer is assigned for in your area, maybe 100, maybe 50 home or 100 homes, based on that. Okay, so that transformer, that neutral I am telling you, that neutral is grounded. It's a DY11 transformer. Okay, means normally the rating of the transformer is 100 VA. Okay, 100 or 110 VA, and the input of the transformer, you can see it is 11 kV. Okay, it is 11 kV by 415 volt. Okay, or 11 by zero point 0.4 kV. Okay, it's transformer, it is 100 VA. You can see in our campus, in your campus you can see some that in just beside of your that means indoor transformers. Okay, in our campus it is also, you can observe some indoor transformers are there. Okay, basically in our campus everything is underground cable. Okay, means the street lighting also be there, but there is not you can see the three lines are not there directly. Basically it is underground cable. Okay, so but some of the cities, you can see there is a, most of the cities right now they are using underground cable, but still most of the place in India you can see that street connections, means in your near RCC pole you can see different wire. Okay, so phase, then according to the balancing. Okay, so load balancing, that phase are connected. Some of your house are connected your R phase as well as your neutral. Some of your house may be connected Y phase as well as your neutral, like that. So, and last one, so six conductors are there. Similar thing also happened here. So that here you can see the parallel wire. So that parallel wire may be used for the protection purpose. Okay, then with some regular interval you can see some booster transformer. Okay, basically pantograph is carrying the current from the pantograph is collecting the current from your line. Okay, so whatever point is there, so is the, it's a long line transmission, like that. Long line transmission means it's not the power system terminology. Here I am telling about long line transmission, means that online means rail means EMUs are directly collecting the power from your from that collecting the power from that wire. Okay, so what happened, so maybe multiple trains are there, multiple emus are there. After some time, okay, after some time or after with regular interval, there is a high chances for dropping down the voltage. Okay, basically continuously it is collecting the power. Okay, so dropping down the voltage, that's why after regular interval you can see some pole mounted small type of transformer. Okay, if you carefully observe that you'll when you are traveling through the train, you can also see. Okay, there is a small transformers are connected pole mounted. Okay, okay, we say that is called boosting transformer. Okay, and you can see sometimes there is a drum set thing is connected, just connected with your RCC pole. Sometimes that is your load. Okay, to maintain the fix up that catenary wire. Okay, so basically pentro huge force is there, pentograph providing huge force to upwards. Okay, so the wire, the catenary wires, if the strain, okay, if the strain of that wire is not been, means it is not connected tight manner, then what happen, loose manner, there is a huge chances for flashing. Okay, so some jumping of the pentro, maybe some discontinuity between your contact wire and the pentro, so in between of them free a place. Okay, there is a sparking. Okay, so sparking is not required. Okay, it is not acceptable in this format. So you should make the proper tension. Okay, so proper tension of your catenary as well as contact wire. So who will who will maintain all those tension. Okay, basically that's why some counterweight, okay, some counterweight is connected, and that also pole mounted. If you see, you can see different disc type of things are there, metal discs are there. There are some number of metal discs, okay, that is connected in just that is mounted your RCC pole, not everywhere, with some regular interval, okay, that provide you the proper strain of your system, of your contact wire. Okay, otherwise if it is loose in manner, so there is a huge chances for the sag. Okay, sagging is not acceptable for this one. Okay, so if the unnecessary sagging is there, there is a huge chances of flashing. Okay, flashing is not acceptable. Okay, so Pento also providing that upper thrust to maintain the zero air gap between your contact wire and between your contact wire and your Pento surface. And for your railway system, so these all are the live, okay, 25 kV line. So from where you are getting that, so one ground is required, otherwise the path will not close and you will not utilize that power. So who will complete that path? The railway track. So the railway wheels, that EME wheels are also being metallic, and that wheels is running just up above of your railway track. So this is your return path. That's why the railway track and wheel is mentioning here as a returning path, returning rails. Okay, and it is a return wire. Here you can see it is a return wire. Okay, so I hope all of you are able to understand. So then here you can see the types of overhead catenary. What are the different types of catenaries are there? How does it look like? So simple catenary is there. Okay, simple catenary means there is a contact wire. Okay, just below the contact wires are there, and just above that catenary wires are there. Okay, this is your catenary wire, and droppers are connected with regular interval. Okay, so this is your simple catenary. Then stitch catenary. Okay, stitch catenary, how does it look like that? So your main catenary, here you can see it is directly connected. So dropper length, here you are splitting that one. Okay, you are making the splitting. The splitting is there, and you can see the configurations of stitch catenary. And last one is your compound catenary. So three types of catenaries are there: simple catenary, stitch catenary, and compound catenary. Okay, compound catenary also you can see multiple compound droppers are there. So different. So catenary, in between the catenary and the contact wires. So first is only one dropper is there. Okay, now you are sharing the force. Okay, why you are making such a manner? Basically the sharing the force. There is a, that the solid bar is there. Okay, solid metal bar of cadmium and copper. Okay, and there is a huge length, so definitely there is some huge weight. Okay, if the dropper is anyhow mishandle that entire the process, so there is a huge chances for there is a huge chances for what? There is a huge chances for discontinuity in between dropper. Maybe dropper may be tear down. So like that, some situation may arise. So you are making the configuration as per your demand. So it may be simple catenary, switch catenary, stitch catenary, or compound catenary. Okay. So three types of catenaries are available. Okay. Okay, now control of DC traction motor. So what are the different controlling method? Okay, so all of you are about the basic electrical engineering, what are the basic concept of the speed controlling of the motor. Okay, so normally you are using that armature voltage control or armature resistance control and the field resistance control. Okay, so armature voltage control and armature resistance control, both the cases, the main idea is approximately. So terminal voltage, okay, the terminal voltage of the motor has been changed. Okay, so not exactly terminal voltage, the armature voltage. Okay, that is going to be changed. Supply may be same. Okay, so terminal voltage may be same, but armature voltage may be changed. Okay, that's why it is called armature resistance control or armature voltage. Why armature resistance control? How do you change the voltage? So you are changing that armature resistance value. Okay, so whatever resistance values are there, that for DC machine, so brush. So initially there is a chances for that vacuum. I think you are aware about the back EMF. So initially high resistance are required. For what? You know that if your terminal voltage is 230 volt, I'm just taking for example, and the size of the motor is more than 5 kilowatts. So the motor armature resistance values are very less. Okay, like that it is 0.5 ohm range. Okay, so if it is 230 volt and current and the resistance is 0.5, so how much current will be there? V equal to I into R. So 230 volt divided by 0.5. So it is more or less coming 460 ampere. Okay, so directly 460 ampere is flowing through your armature winding for the DC series motor, and you know that DC series motor armature resistance value is not so much high, so its value is less. So now you know how much losses are there. I square are loss. So I value is 460. Okay, ampere. I square means 460 whole square into R. R is 0.5. So can you imagine? So huge values of power will be developed. So that's why huge values of power will be developed. Okay. So the rheostat is required. Okay. So that you can. That's why huge power will be required. And how to counter such type of resistance? So you have to incorporate some resistance part series with your armature winding. Okay. So that additional resistance rheostat you are going to be added. Okay. So here you can see the rheostat portions. You can see that is connected series with your armature and the field winding. So in case of DC series motor for the tractions, okay. So field winding, armature winding, and whatever external resistance all are connected in series. Okay. So when that current value, when that values is high, so you make the full resistance, then gradually you can cut the resistance value. Okay, why you are making like that way? So basically, when back EMF is zero, so that everything is happened when the back EMF is zero. So after some rotations, so gradually back EMF will be developed. Okay. So some induced EMF. So induced EMF will be developed. Why it is called back EMF? That induced EMF, why it is known as back EMF? Basically, that rate of change of cutoff flux is there. Okay. So that directions. Okay. That induced EMF directions and that current. Okay. So current is cause, induced EMF is the effect. Okay. Current is flowing through the armature winding in the motor. That's why some armature field is developed. That armature field, magnetic field, is interacting with your main permanent magnet field. Okay, so now there is a huge interaction between. You will get the resultant flux line, and your motor will follow the resultant flux line, and it starts rotating. After rotation, there is a cutoff flux inside of that fluid. Okay, so that rate of change of cutoff flux may cause for induced EMF. Okay, that's the basic idea. So initially back EMF is zero, no movement of the motor is there, no movement of the armature. So if you gradually increase of the back EMF, okay, so countering voltage will be increased, and gradually you will get the value, and you can automatically, and not automatically, you can increase you can also change that value. Okay, so here the same thing also there. Initially high, initially based on the current rating, here you can see some contact wire and the rheostat grids are there. Okay, so by as per your demand, you can connect the contact wire, and you will collect and you can control the speed. Okay, you can control the speed of that motor below base speed. Up to base speed, it is allowed up to base speed. After that, what happened? You need to follow that other method. Okay, so this way, so where you can see the rheostat grid and it's a contact wire. Okay, by that way you can change the motor speed of the armature. Okay, so speed of the armature as well, so you can change the speed of the motor. Okay, so here the basic idea I have given. So it is called rheostatic control. Now series parallel combination. So normally what happened? So your motor, suppose motor is there. Okay, then there is some you know that brush is there. Okay, so brush as well as bearing. Okay, all are connected through the motor through the shaft. Okay, so so series parallel combinations means suppose you want to drive your motor for high voltage applications. Okay, so what you need to do, you have to add both the motor. Okay, maybe more or less same rating. Okay, you are connecting them with that high voltage configurations for high current applications. Okay, then what you need to do, both the motor may be working just like a parallel, so you have to design the sequence. Okay, you have to prepare the sequence how to control the series parallel combinations of the motor for achieve your reference value. So whatever value you want to achieve, based on that you can do it. So this is the control process for the DC tractions. Here you can see field weakening method. So if you want to more speed beyond your base speed, so who will responsible for that? So field weakening method or field control method. Okay, so in that case you are adding the rheostat series with that field. Now you are changing the current. Okay, now you are changing or varying that field resistance. So automatically that field current. So it's a parallel path. So automatically field current is changing. Based on the changing of the field current, motor RPM also been changes. So here you can see that this is series motor for field weakening method. So field winding is connected with the resistor grids. Okay, a lot of resistors are connected, field shunt contactors are there. It is a field winding. Okay, field weakening resistance, this is a field weakening resistance. Okay, so all the things are possible and you have to prepare it as per the guideline, meaning whatever values are given. Another thing is that is called field changing switch, field changer switch. Okay, so it's a DC motor, so there is a problem of that directly if you change the polarity, so it is not. So whatever residual magnetism will be there, so if you reverse the polarity, so automatically it will be reversed, so that may damage or demagnetize your residual magnetism, that can having effect to the motor. Okay, so you cannot stop that residual magnetism. Okay, so that's why there is the auto changer switch, money changeover switch. So when you are changing that any terminal or whatever things will be changed, so you have to change the switch. Okay, then whatever previous conditions was there, it will be maintained. Okay, so that's the very important features. Okay, of our traction system and control of the DC traction system. Okay, so control of the induction motor. So you know that speed control methods. Number one is rheostatic method, pole changing motor, cascade control, combination of cascade and pole changing control, and any other method you can see. So for that induction motor, what happened? So different method, you know that changing of the speed. Okay, as well as braking, different braking system also there in your locomotive. Number one is plugging, rheostat braking, regenerative braking, and for the mechanical braking means composite, air brake and vacuum brake, and finally magnetic track brake. So based on that braking, okay, so I will start discuss about the braking, what are the different types of the braking, why they are important, how it is working. Okay, some of the portion I will discuss in my next class. Okay, so if what are the important features of the braking. Okay, till now any doubts are there, so you please ask me. If there any is there any doubt, so you please let me know.